In this video, we're going to be solving rational equations. So let's begin. Okay, this first one is x over 3 minus 2x over 8 equals 1. The whole idea that I am trying to teach you is that it is okay to multiply by the least common multiple, or you can also call that the greatest common denominator, so that we can just get rid of the fractions. It's possible to solve equations with fractions, it's just more difficult. And so I'd like to show you a way where you can actually get rid of those fractions. All right, so if we have this problem, if we look at these denominators, 3 and 8, since 1 is a whole number, it might be helpful just to put a denominator of 1 underneath it. Okay, least common multiple is 24. Okay, so here's what's going to happen. Above this first fraction, I'm going to write 24 with a set of parentheses, and then I'm going to put 24 again and 24 again. Okay, because this is an equation, all things have to be equal, or the math operation that I perform has to be the same to each term. So each term is going to be multiplied by 24. Okay, so I'll show you what that looks like. This first one's going to be 24x over 3 minus 24. I'm going to just put that 2x in parentheses. I'm not going to multiply it yet. Over 8 equals, we can just do 1 times 24, and we don't have to put the denominator back. Okay, so we still have fractions, but before we start solving for x, I want you to notice that we have some terms that can simplify here. 24 divided by 3 is 8x, and then 24 divided by 8 is 3, but there was already a 2x, so this is going to be 6x equals 24. Combining those together, this will be 2x equals 24, and then just divide both sides by 2. Okay, and then this problem, x equals 12. All right, let's take a look at another one. Okay, this is 3 plus y over 5 equals y over 2. 3 is a whole number. It's not a denominator, so I think it's helpful just to put a denominator of 1. That way you don't get it confused when you're trying to find the least common multiple. We're just really looking at the denominators 1, 5, and 2. 3 is not part of the denominator. So the least common denominator here, or multiple, whichever you want to call it, is 10. So just like before, we're going to multiply each term by 10. Here's what that's going to look like. It's going to be 30 over 1, which we don't really need that, but we'll put it there for now, plus 10y over 5 equals 10y over 2. There are parts of these fractions that we can simplify without messing up the entire problem. Okay, just another way to write 30 over 1 is just simply to write 30. Another way to write 10y over 5, a more simplified way, would just be 2y, and then another simplified way to write 10y over 2 would be 5y. And so this process that I'm teaching you, it goes from, a really difficult problem with fractions to an equation that doesn't have fractions, and it should be, fairly easy to solve if you've had any kind of pre-algebra. We're going to subtract 2y. This is 30 equals 3y, and then of course divide both sides by 3 to get y equals 10. All right, take a look at this one. We have denominators of 10, 15, and 10. So another number that 10, 15, and 10 could go into, or a common denominator, is 30. So I'm going to start the problem by writing parentheses 30 at each numerator. Okay, so this is what this one's going to look like. I'm going to keep the 30 outside. I'm not going to multiply it to the u minus 5, and so I'd like you to do the same, and we'll do the same with the u plus 8. Let's just keep the 30 on the outside and just put u plus 8 in its own set of parentheses. And we can actually do the same with the 7. We can just put the 7 in parentheses by itself. Oop, I forgot to put all the denominators. This one had a denominator of 10, denominator of 15, and denominator of 10 again. Once again, we have parts on all three of these fractions that can cancel. When we go to simplify the first fraction, this would be 3 times u minus 5 plus 30 can be simplified with 15. That leaves a 2 times u plus 8 equals, and then 30 divided by 10 over here would be 3. So that process, that's the process that I would like to teach you, is that you can take an equation with fractions and clear the fractions out to get down to this step where you just have a regular equation with whole numbers. All right, so let's go ahead and finish this one up. This is 3u minus 15 plus 2u plus 18 equals 21. Okay, now we need to combine like terms. 3u and 2u makes a 5u. It's negative 15 and positive 18 is a positive 3, and then equals 21. We'll continue solving by subtracting 3. Now divide, let's move it up here. Divide both sides by 5. When you get to an answer like this, I want you to leave it as an improper fraction. That is okay. If the improper fraction could be simplified, like if you could divide both numerator and denominator by 2, I'd want you to simplify it. But in this case, 18 and 5, just leave it as that fraction. Okay, I believe there's one more. Okay, let's take a look at this last one. This last one is different because there's binomials in the denominator instead of numerator. All right, let's take a look at this last one. Notice that we have minus 3, which is a whole number, and check out our denominators. They're both z plus 7. And so, yes, we're going to take that entire binomial and we're going to follow the same pattern, multiplying z plus 7 to each term. We have z, which is from the original fraction, parentheses z plus 7 over z plus 7 minus 3z plus 7 as part of a denominator to multiply by. Okay, let's finish this one. This is negative 1 times z plus 7 over z plus 7. Now we're going to go through and simplify the fractions. Notice that the z plus 7 and z plus 7s cancel, and the same is going to happen over here. Z plus 7 and z plus 7 will cancel. Now the problem looks like z minus 3z minus 21. All I did was just use the distributive property here, equals negative 1. Okay, because these two z terms are on the same side, you can combine those together to get 2z minus 21 equals negative 1. Add 21 to both sides. This is negative 2z equals 20. And then once you divide both sides by negative 2, you have z equals negative 10. So those are just a few examples. These can get pretty difficult, just depending on, what the problem gives you, whether you're solving it from the textbook or from your web assigned homework. Please contact me. Please text message me. Send me an email, ask a friend. I'd love to help you. All right, see you later.